Hi, I'm Damian. I'm most of the time wrong. Sometimes I'm right, so don't take anything what I tell today as given. It works for my case. For you, it should not work. I don't like write documentation. I don't like write code. I don't like write tests. I like read code. I like delete code. I like talk about code. And I like solve problems, not write code, basically. I work for Babylon. Our mission is to put an accessible, affordable health service into hands of every person on the earth, and of commercial. What I think about microservice. So when I'm writing microservice, it's the level of code I like. So basically, I don't think all the glue, all the frameworks are the part of the microservice. This is my boundary. So I have some JSON, I have my database, I do something and my code, and that's all what I want to have. But that code has some problems. It needs tests. So I write tests like that for that, and it's really simple. A happy path. I just put some user to my repo, update it, check if it's updated, but it's not enough. I need more tests. I made that, and I'm pretty sure I covered everything, but this is my check if user is blacklisted. So I expect that username is a string. It's not always happening because I have delete on my entry point. So I need something to check if my inputs are according to the contract. I can use MyPy for that. But to use MyPy, I need types. So let's change about our microservice to just that function. Oh, I forgot about the rest. Doesn't matter. So I have just the user, check if its username is blacklisted, update it database, it works. But how to make that user object? I can go the simple way, just use the tuple. Most people like this, simple, easy. But you can shoot your foot with that because you have different types, you have equality. And it's equal because name tuple are just like tuples, so the names are not the part of the contract. What to do? Let's have a class. So we write that code. We have some function that generate our class from dict. It looks nice. So I don't tell that you don't need a unit test. MyPy tell you that your inputs are according and outputs are according to the contract. So you still need lots of unit tests, but you don't need unit tests for what if somebody put int in the place of string. So we need more classes and add more data and just fill inputs because we always find something that is not present in our type. But our type is still mutable. I don't like mutable. It's for your data classes, you don't need to shock people that something changed in the fly. So hide attributes, try to do it immutable. So we did write more, and it's lots of lines, and I don't like to write code. So we need finish this madness. What we need function, we give it recipe, and it produces type for us. it's what we need because most of the time we need simple types. And there's few libraries that do that. There is data classes, it's built in. There is attrs, what I will talk about today. And type it is really nice, but use name types and it's better. But if you like, I suggest to look on that. So I use attrs only because I put my data classes, my API contracts to my users on my microservice, and not each of one use Python 3.7. So because attrs are compatible with older Pythons, I decide that. It's not, I'm not religious about that. It's why it's easier for my consumers to use. So how you can use attrs? You just define the class, put decorator before that, and there are other things that behave similar way, but they require you to create class from their base. They require you to add some meta classes, and I like attrs and data classes because you still can use meta class, you can still have your own inheritance tree, and they don't change the use of class so much. I go too fast. You can use it that way, add more parameters to data class. So in this format, it will pretend that it's immutable. It's not immutable, but it will pretend it's really hard to obey that. It will add everything to slots, and you don't need to use attrib for all the attributes because it's added automatically. And if you want to add default value, you can just add the default value. If your default value is mutable object, you can add just factory to generate that default value. You can clean up inputs. I almost never do it because data classes are my contract in my microservice, so I have as little there as is possible. It's just the types, but you can do it if you like. You can add validation in different ways. There are some nice predefined validators. You can have own function validate that. And it has some usable tools. You can list fields of your data class. If you like your class immutable, you want to create object that is based on previous one with some changes data. So there is evolve function to do so. But we talk JSON, so it's easy to get the string, generate JSON, but we have our data classes and we need the glue from simple format like this list to our types. So we can do the simplest ways. There is the way to change your data classes to dictionary. You can create function that will generate your classes, instances. But there are some problems, like sometimes you want types like that when something is the union, and then your structure function, okay. Okay, so for that, we can just use chats. It's basically define all that edge cases that we don't want to implement by ourselves. Why go with the way that I will create function and we'll do everything by ourselves? Basically, chat cattrs, I have no idea how to spell that, is single dispatcher with some predefined values and nice API to add more data. And so everything what you do, you just put the dictionary, put your type, and for attrs, it will use your type to generate your objects. And we are using JSON, so we don't want to be too strict. So basically, if you want to have change your API in some way, most of the time you first add to the client new value and then migrate it in smaller steps. So you want to allow to use JSON with new value with types that don't know about that value yet. So you can use hooks for that and change the way how that's structured. So this function is just not strict adds. So it uses the internal SAT structure from internal function to structure adds classes, but it will skip all the fields that are not exist in the class. So you can have JSON with additional fields, but you will ignore because your type don't have that fields yet. It's really usable for APIs. And you can put in the system the objects that not are the adds object. So date, decimals, everything can be handled automatically. And it's big win. But there are some problems. My API that I work with was in that format. So basically, there was a field to tell what type the subfield was. And the types on the value were really similar, but for our system, they should be handled differently. So they were different types with almost the same fields. So, and for that case, it's really hard to solve that problem, but still, it's possible to solve that. We can generate class for our base class for our union, the base class structurer. So it will know which classes we expect in our value, and then use structure full function to make sure we use correct class to structure the value field. And in that format, it will work. But there is lots of details from the type. You don't want that. So it's really easy to pretend that you write meta class without writing meta class. So I have a base value for all the values type that where you can register your types to that base class with one enum that keeps the name of the type. And for that, you can have just this code. So you have one class A, class B, and that are values, and you just register them which type they expect. And the unstructured function is really simple for that. And with that, you can just structure the type, and you will get correct results. Really useful. And sorry. Okay. The bonus is you can write really easy tests to check you implemented all the types, because most of the time people add new type to the enum and forget to create the class for that enum. And with that test, you just always know that all the enum's values have own types, and It's really easy to not forget about that. And the problem is that that converter is global, but you can have your own converter. It's just the module. You need to hook it and import it in one place. But for my case, I have microservices that use different set of APIs, and for different set of API, I have different set of types, and for each different set of types, I have their own structure module. So you need to remember that you use for this API this structure and module, and for second API second structure module. But nothing unexpected will be added to your structure unstructured, because if people use your library, they might override your structure function, and it's not perfect for you. So let's back to start. How I use it in microservice. So I have such function. I have my JSON API decorator. I use it in that way because on my test I want to have ability to import my update user function. I don't care about decorator. I test my decorator in separate way. And decorator look a bit scary, but nothing magic. There is nothing magic in here. I just have two types for the decorator: get normal JSON, structure it, and unstructure it after that. In the whole stack, it looks like I have framework. I don't care which one. I have my Swagger OpenAPI file, and I do my validation of JSON with that Swagger. I have linter to check that my types are the same as defined in Swagger. So I know that on the start of my view, my types are always correct. And all the types checking are done with my Py. It makes life easier. Don't be scared of the types. It makes refactoring easier. It makes changing code really easy because you really know that you can switch arguments and nothing bad happened. You can rename an argument, nothing bad happened most of the time. Yeah, that's all. So thank you. Any questions?
Thank you, Damian. That was great. Does anyone have any questions? Yes, Emma.
Hey, hello. Thank you for the talk. In one of your slides, you made a comparison between all the solutions that there were, and you were saying that attrs was way more flexible than dataclasses. Can you expand a little bit on that, please?
The problem is dataclasses are built-in, so they created that library after CLAS, based somehow on CLAS, but they remove few functions that they cannot agree that they are good. So it's smaller, more compact, still powerful, but it's smaller version. If you have external library, if you don't like something, you can fork it and use it. But with built-in library, you cannot. So if I have no requirement that my API are used by clients that are using Python 3.6, I think I will use dataclasses and force stats to use dataclasses because it's quite easy. But there's my requirements, so I'm using, I don't like add new requirements to the project without reason. So I would use dataclasses, but it's reasonable to use that for that case.
Thank you. Any more questions? Okay, if there are no more questions, let's thank our speaker one more time.